This is the hardness chart out of the finished file. 41 points and 5 straight horizontal lines across all of them. Lower spec, upper spec, center line, lower control limit, upper control limit. This lecture is about those 5 lines and nothing else, because how they are made is the one idea the rest of this workbook is built on. Click the upper spec line and read the series formula. Every chart series in Excel is one of these: a name, a set of categories, a set of values, a plot order. The part that starts this lecture is the values argument. It has to be a range of cells or a defined name. It cannot be a number. Try it. The upper spec for hardness is 22. Type 22 into the values argument and press enter. Excel will not take it. A series is a list, and a list of one value is not a line across 41 batches. To draw one flat line at 22, you need 41 copies of 22. And tomorrow, when the next batch is released, you need 42 of them. That is the whole problem. It sounds small. It is the reason most quality dashboards are 3 times wider than they need to be. Here is the standard answer, and I want to build it properly rather than sketch it. Put the constant in a cell. Then next to the hardness column, start a new column and reference that cell. Equals $Q$4. Absolute, so it does not walk when I drag it. Enter. Drag it down 41 rows. There is your line. 41 copies of 22 in cells, and a chart series binds to that column happily. That is the published answer, and it is a good one. John Peltier, who the Excel charting world asks when it does not know, writes it up 2 ways. One is the helper column I just built. The other is a dummy range of 2 points added as a scatter series. So the line runs from a start point to an end point, instead of being copied down the sheet. Neither is wrong, and I will not pretend otherwise. What makes them awkward here is this chart's horizontal axis. Its categories are not cells I typed. They are a name that measures the batch column and takes whatever length it finds, so the plot is a different width on different days. A 2-point line needs an endpoint, and the end keeps moving. A helper column has to match an axis that changes length on its own. Now cost it out, because a technique that is fine once is not automatically fine 40 times. 10 attributes down the side of the spec block. 5 reference lines across the top. Lower spec, upper spec, center line, lower control limit, upper control limit. 5 lines times 10 attributes. 50 helper columns, if every attribute carried the full set. This one does not quite. 7 attributes carry all 5 lines, and the other 3 are one-sided, an upper spec and nothing else. 7 5s are 35. Plus 3 is 38 columns of copied constants. 38 columns, and not one of them contains any information. Every cell is a copy of a cell somewhere else. Then a batch is released, a 42nd row appears, and all 38 are 1 row short. Everyone has to be dragged down again by hand. You have to remember all 38. And miss 1 and a chart quietly draws a spec line that stops before the last batch. Control Z. I am not keeping it. There is another way with no cells at all. Control F3 opens the name manager. New name. Call it calculation.hardness.usl, following the convention from section 3. So the name already tells you it lives on calculation, it is about hardness, and it is the upper spec. And now 4 moves in the refers to box. I am going to build them one at a time and look at what each one returns. Move 1, row of calculation.batch. Select it, F9, and look. F9 evaluates whatever you have selected and shows the answer in place. And it is the move that makes everything in this lecture visible. There it is. 2, 3, 4, down to 42. A vertical array of 41 row numbers, because calculation.batch is the spine, and the spine is an offset with a count A inside it. Nothing in there says 41. It is 41 long because there are 41 batches, and it will be 42 long the day there are 42. Escape, not enter, so the evaluation does not get written in. Move 2, and this one carries the whole idea. Wrap it in is number. F9, again. True, 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 41 times. Every element is true, and the reason why is stronger than it looks. Row can only ever return row numbers. There is no data you can put in those cells that makes row return something that is not a number. Blanks, text, an error, a half-filled column. Row does not look at contents, it reports position. So his number of row is true for every element, always, and the array it hands back is exactly the shape of the range and completely indifferent to what is in it, which means you should stop reading ISNUMBER as a test. The name makes it look like one. It never tests anything here. What it does is construct a shape, an array with the same dimensions as a range that resizes itself, filled with something you can do arithmetic on. That reframe is the technique. The rest is consequence. Move 3. Multiply the whole thing by the cell holding the constant. Calculation $Q$4. That is where the hardness upper spec lives, and it holds 22. F9. 22, 22, 22. 41 of them. Multiplication coerces true to 1, so one cell times 41 trues is 41 copies of that cell. That is the broadcast. One scalar spread across an array, no loop, no drag, no cells, and the length came from the spine. Move 4. Wrap the whole thing in index, then put a comma and close the bracket. Both of index's arguments, the row number and the column number, are left out entirely. Index with both arguments omitted returns the whole array. And I will be straight about this step because it is the one people build drama around. The name works without it. Bound to a line series unwrapped, it draws the same 41 points. What index buys is that it pins the result to a concrete array reference, the form Peltier documents for chart names that carry arrays, and the form I would rather ship. 3 moves make the array. The 4th hardens it. Before we use it, put it next to the 3 things you are probably about to try instead. 2 of them behave differently from how they look. The 3rd is fine. The 1st is double minus, batch not equal to empty quotes. 2 minus signs turn true and false into 1 and 0. And it works. It also reads the contents of the batch column. Blank 1 batch cell, and that position comes back as 0. The array is still 41 long, but one point of your spec line drops to the axis and climbs back out. A spike straight down through a straight line. The second is, if batch not equal to empty, then the constant. Same reading of the contents, same dive, by a worse route, with no value if false, that position comes back as the word false, and false pushed into a chart series plots as 0. The 3rd is if of row, then the constant, and I am not going to kill it because there is nothing wrong with it. It is built on row, so it never reads a cell's value, and it is safe from the contents for the same reason mine is. Put an error, some text, and a blank down that column, and it hands back the constant every time. If you have written it that way, you have not made a mistake. So the comparison is 2 against 2. The 2 that read the batch column can have a point knocked down to the axis by an empty cell. The 2 built on row cannot because row reports position and never looks at a value. Between those 2 I use ISNUMBER, and my reasons are preferences, not corrections. It multiplies cleanly. True times a number is that number, and it reads as a declaration of shape rather than a test. I would rather tell you that than invent a fault the other one does not have. So now repeat it. The same name for the lower spec pointing at column P, the center line, column R, the lower and upper control limits, columns W and X. Same formula every time. One cell reference different. One thing that will annoy you the first time. Inside the refers to box, the arrow keys do not move the cursor. They point at cells and paste references into your formula. F2 switches the box out of pointing mode into editing mode, and the arrows behave again. Learn it here because you are about to do this 38 times. 38 of them, one per reference line the file draws. Here is the scoreboard. 38 names against 38 helper columns. Same lines, same charts, same picture on screen. The names occupy no cells, and nothing is dragged. Ever. The calculation sheet's parsed data still runs from column A to column M and stops instead of running out to the right in a field of copied constants. And the dashboard sheet holds no cells at all, which is only possible because none of this is stored anywhere. And then the test that matters. Add a batch. Type the row. 42 points, and all 5 lines are 42 long. I did not touch a chart. I did not touch a name. I did not drag anything. Count A saw one more entry. The spine grew. Row took the shape of the spine. ISNUMBER kept it true all the way down. The multiplication filled it, and index handed the whole thing to the series. Every reference line in this workbook is exactly as long as the data it crosses, because it is not stored anywhere. It is derived, every recalculation, from the same measurement of the data. Control Z back to 41. And I should say where the shape of this comes from, because I did not invent it. An array of ones inside a defined name, multiplied by a value, is an old idea in Excel charting. Tushar Mehta published a version years ago, building the ones as row divided by row and handing it to a chart series for this same job of keeping threshold lines off the worksheet. What I chose differently is number of row instead of row over row, and the index wrapper on top. Those are preferences, not improvements on him. Remember them as 4 separate moves rather than one long formula. Row of a self-sizing range gives a shape that maintains itself. ISNUMBER makes the shape independent of the cell contents. Multiplying fills it with a constant. Index hands the array over as one reference. The next section is the charts, and every one is built on what you just made. The band behind the points is 2 of these arrays stacked as columns with no gap. And in the lecture after that, I change one spec limit and you watch the band move. The out of spec points reflag and the capability index update with nothing touching a chart. This is a real quality report, not a teaching file, not a tidied up example. A pharmaceutical site built it. It ran for years, and it has 7 charts, 3 drop-downs, and a calculation layer that does something most Excel courses never show you. It also has defects, real ones. A parse layer that takes a mid-range and calls it a mean. 67 dead charts nobody removed. Stale filter names that survived every edit. I kept all of them, because the thing worth learning here is not how to build something clean. It is how to read something real and work out what it assumes. We rebuild it from raw data, one sheet, text off a certificate of analysis, and nothing else. By the end, you have the whole dashboard built the way the original was built, and you know why each piece is shaped the way it is. 4 techniques carry the whole file, dimensional authority. So one column decides how long everything else is. The lag pair, for a moving range that never drifts out of step. The broadcast, where a defined name draws a line across a chart while occupying no cells at all. And the tolerance band, which is 2 of those arrays stacked so the chart reacts to a spec change with nothing touching the chart. There is no dynamic array anywhere in this course. No let, no lambda, nothing from the last few years. It runs on Excel 2016 and anything newer. That is deliberate, because these techniques are older than dynamic arrays, and they still solve a problem dynamic arrays do not solve. Do not. You also get the file. 4 workbooks that chain, so every section hands you a checkpoint you can open if yours has drifted and you never lose your place. If you have ever opened somebody else's workbook and not known what to trust in it, this is the course. Let us go and read one properly.